Okay, welcome to day 3. We haven't hauled me in for jury duty yet, so able to proceed as normal for now. Okay, now, so what I plan to do today, we'll see how it goes, is basically break down the class time into two parts. One, so first I'm going to continue showing you various Python essentials. We left off last time with for loops, and we're going to continue with that. But also, as I go through these things and show you various scripts that I've written, I'm going to assign you certain variations on those scripts. And so what I'll do is, at some point, I'll stop with the tutorial part, and by then I'll have pointed out a few problems. So really, they are explorations here in my textbook that are originally written to do certain things in MATLAB, but what you'll be doing is implementing those same things in Python based on things that I've shown you. So then the second part of the class, I'm going to, so I want you guys to be working on these things in class where I can go around the room and help. If you happen to finish all the ones I've assigned, you can go. But that way we can make sure that everybody is following along. Now, for a smooth transition from last time, I'll make this a little bigger. Okay. So here, I have, so there's a bit more posted from day 2 than before, because besides the customary video and the tutorial script, these are Python files that I stepped through during class. So what I would suggest is, if you haven't already, go ahead and download these from the site, especially compute mean. That's the most important one, because you are going to be modifying that today. So go ahead and save those somewhere. And the other thing, therefore, that would be good to do is, as you're downloading those, assuming you're using Spider like I am, where we have the current directory set. So this is the default up here, but all of my files I have in my own directory here. So whatever folder you save those .py files into, it'd be good to have the same folder up here in Spider, so that when you are importing things or creating new files, that you're just working in that one folder the whole time. All right. Okay. Now, let's see. So so right here we have, this is the last file that I stepped through last time, compute mean, that imports NumPy and then generates a random 10 vector and then computes the mean of the numbers in that vector. Now, so the first problem that I will assign so this is exploration 1.2.15 in my textbook, just done in Python rather than MATLAB. So what I'll do is put that up in front of you. Okay. Okay, so you'd be taking the compute mean script and just modifying that to get a new script. So save it to a separate file, compute variance, that will use this formula to compute the variance. So this is something that during the second part of the class you guys can go do. So the aim is that based on understanding what's in compute mean, that you'll be able to make whatever changes are needed, because it's going to be using a for loop in the same way, etc. But notice, of course, that the mean is needed to compute the variance. Okay, so that's your first mission. Okay. Now, the next file we'll take a look at. Okay, uses a for loop and an if statement together. Okay, so I've called this script find max. So I'm going to go ahead and run it first. So I can either import it, or I can just, well, actually, yeah, I'll go ahead and do that. So importing will have the effect of running this. So all it does is it creates a vector of 10 numbers, random numbers uniformly distributed in 0, 1, prints out x, and then it just goes through and finds which element is the largest. It's this one right here, and then goes ahead and displays that. Okay, so what I'll do is step through this, and then I will assign you a modification of it also. So here we're using a rand function that's part of numpy.random to generate a random 10 vector. So if I wanted actually, if we go ahead and look up rand. Okay, so I'll go to the SciPy documentation here. Okay, if I look up rand, and remember, it could be multiple modules, so this is what I want in numpy.random. So its arguments are simpler interface than most other functions. You just pass however many dimensions you want. So I only pass one number, 10, so it creates a one-dimensional array. Whereas if I wanted a matrix, I'd pass number of rows, comma, number of columns. And you can use this to generate any dimensional array of random numbers. Okay, so then we go ahead and print out x. So the idea is I want to examine all of the elements of x, and I make a variable x max is so its meaning is the maximum element found so far as we examine x from beginning to end. So then once we've examined the whole thing, then it would be the maximum element. So we just go ahead and set it equal to the first element initially, because certainly that's the maximum found so far where we've only examined one element. And then we examine the rest of x. So notice here I have a for loop that uses range 1, 10. So starts at the second element of x. So it's going to start x square bracket 1, 2, 3, all the way up to 9. Remember, it's the zero-based indexing here, because we don't need to examine the first element all over again. So it's a little more efficient this way. And all we do is, as we come to each element, now we have an if statement inside this for statement. So because of the indentation, we see that this if statement is run during each iteration of the for loop. So more so than other languages, indentation is essential. So it just compares to the maximum. And then if it is greater, then we go ahead and update Xmax. So maintaining the meaning of Xmax the whole time through the loop. That is always the maximum element among the ones examined so far. So when we come to the end of a loop, Xmax will be equal to the largest element, and then we go ahead and print that out. Okay, so any questions about what's done in this file? Okay. Actually, to make things easier later on, I can show you how I update my site. So I have that file here, find max, and I need to. So what I want to do is put it on the site. Normally I put it up after class, but I want to put it up now. Oh, it's already connected. I didn't know that. Okay. So I'll go ahead and find my 684 folder and upload it there. But then I need to put up a link to it. Okay, so for June 12th. Find max.pi. What? Oh, just ordinary HTML. And I worked in web design in the mid-90s, so that's about where my knowledge is. Okay, early 2000s. So now, if I, and also you, refresh, it's in a frame set, so if, like in Firefox, I reload the frame. Okay, so now that is available for you. Yeah.
Just refreshing that tab won't do it?
It depends on how your browser behaves. Because what it might do is might only if it refresh the main page that holds the frame set. It might not be smart enough to update every frame. What?
How do I, if the little refresh button on my tab is on, do I need to close the tab and open the tab?
Which browser are you using? Oh, okay. Because, well, so it won't let you like right-click in the frame and reload just that frame. Oh, okay. Because Edge is the successor to Internet Explorer, isn't it? Or, yeah. Because I remember when I had Internet Explorer, I could configure it to reload the page every single time. Also, if you clean out your cache, that would definitely do it. Although it'd be a pain to clean out your cache every time. What? What?
It's not there.
Okay. Is anyone seeing it?
Yeah, it comes up.
Okay.
Now, one thing I am noticing
Uh-huh.
is my old computer doesn't like the edu domain.
Uh-huh.
and using the USM public, your page won't come up.
Really?
Yeah, I know.
At all? Or?
Yeah, at all. So, for some reason, you do not deserve to be within their firewall.
Okay.
I don't think it's that controversial, but.
Okay. Here's what I'll do. When I come to the end of this part of a class, if anyone's still having difficulty, then I'll email this and any other similar files to you guys, so you'll all have it. So, thank browsers. You'd think that...
Yeah, you think they solve these problems, but they don't.
Yeah. That's why I use Firefox, because it seems to be better about them than other ones. But every time I try another browser, I always regret it. Okay. Okay. Any questions about what's in how this code does its job? Now, what I have in mind, we're doing that's a MATLAB version of the same thing. Okay, so this is the second thing that I will assign. So modifying that to get a new script, find max POS, short for position. So it'll print out two things. It'll print out the max, but it'll also determine the index at which the maximum was found, and print that out as well. Now, in MATLAB uses 1-based indexing, so I said print out the index from 1 to 10. So in Python, you can either go ahead and print out the index, also which is between 0 and 9 in this case, or if you want to print out the position, 1 through 10, you can just add 1 to it. So up to you. And something to think about, though unlikely to happen, because we're dealing with floating point numbers here. You'd have to have some way of determining how you settle a tie. What if there are two elements that are equal that are the largest? You have to make a decision. Do you print out the first one of that instance that you find, or the last one? So that's a interesting point. So if we have an opportunity toward the end of class, we can talk about that. Okay, so I'll make a note of that here in the console. Whoops. Okay. Okay. All right, so that's something we'll take a look at later. Let's see. Okay. Now, so for the next item is Gauss illumination. Now, I actually have that in one of my files, but that's written as a function. Haven't talked about functions just yet. I don't want to jump the gun on that. So what I'm going to do instead is at the oh, you know what? I need to update this. Okay. The version I uploaded might not have had all my comments. So, okay. So maybe it's good that you couldn't get it yet. Okay. So, at the risk of greatly embarrassing myself, I'm going to implement this live in front of you. So a script which generates a random matrix and then performs Gauss elimination on that matrix to reduce it to upper triangular form. And later, it'll be like your first graded assignment is something that's going to build on that. But we'll get to that after the tutorial. So I'll go ahead and create a new file here. and I will save it as Gauss-lim. Hopefully I don't already have it in here. No, I don't. Okay, good. So I'm going to need NumPy, and I'm going to create a random matrix A. This is helpful, where it doesn't always do this when I want it to, but as you're going through, like here, this is all the functions that are, or attributes that are available under np.random. And the one I want is rand. Hello? Okay. And then, as I put in a parenthesis, Spider will show me what the arguments are supposed to be. So I want a 10 by 10 matrix. So I'll put in 10 and 10. So this is different from MATLAB. MATLAB, if I had put just 10, one argument, it would give me a square matrix. But as you saw in the previous example, but just putting 10 by itself would give me a one-dimensional array of size 10, so a 10-element vector. Okay. Okay. Now, to make this actually, so I'm going to set n equal 10 and make this n by n. So that way I'm not hardwired into 10 by 10 necessarily. All right. So this is going to happen. Maybe changing my mind a lot as I go. Okay. So now what I'll do is reduce this to upper triangular form. But I'm going to show you one important element, one important aspect of matrices in Python that is completely different than MATLAB. So the idea is A is my original matrix, but I want to reduce to upper triangular form and store that in a matrix U. So here's what I'll do. I'll go ahead and say U is equal to A. The idea being that A will retain its original content, original element entries, and then U will be the upper triangular form, or like row echelon form. Okay, so I need some for loops. So I'm going to have J in range n. Actually, I don't need range n. N minus 1 is good enough. This is a square matrix, so I'll need to look at the first n minus 1 columns. Work on columns 1, 2, up to n minus 1. So indices 0, 1, 2, up to n minus 2. So I'm leaving out the last column. Okay. Now I'm auto-indented. Now, in this case, we're not going to bother with pivoting. So this is the simplest form of Gaussian elimination. Pivoting is something you'll deal with in an assignment. We talked about last time about how you swap rows of a matrix, so that'll come in handy when you do that. So now, for each column, I want to eliminate entries starting from a diagonal, so starting from the jth entry plus 1 all the way down. So I need to start at j plus 1, and I need to go all the way to the bottom, so n is what goes down here. So this is all subdiagonal entries. Okay.
Why is there a colon? Is that semicolon?
Colon. Yeah, so that's what Python requires for if statements, for statements, while statements, any of those. Also function definitions. So it's how it knows a statement is finished. Okay. Now, I need a multiplier for Gaussian elimination. So I call it Mij, and that would be U. I would do all my work on U, Ij. That's the element I'm eliminating, divided by Jj, the corresponding diagonal entry. So we'll just have to hope that it's non-zero. Okay. And then for K, going from column J all the way to the end. Now, this is something that came up last semester in 561, where I actually started at J plus 1, and some thought I was incorrect. And actually, J plus 1 is almost needed to get the entries of U, but I actually want the matrix to actually come out being upper triangular. So what will happen is when I perform the elimination, I'll say U I K equals itself minus something. So now if I do this, this is the clearest description of the operation. U J K, but since I'm updating UIK, I can say UIK minus equals all that. So that has the same effect. So this is what actually performs the row operations. Okay. And that's it. That's the Gaussian elimination algorithm that will reduce U to upper triangular form. So when K is equal to J, then I have Uij equals Uij minus Uij over Ujj times Ujj. So in other words, Uij will just turn out to be 0, as expected, as part of getting upper triangular form. It's a waste of arithmetic to do that, but we're not concerned about that right now. At least we're able to see for ourselves that the elimination is proceeding correctly. Okay. Is there any questions about what happened here?
I just love it.
Yeah, the code's unbelievably short. Yeah. Yeah. So as long as you keep track of the indentation, which just pretty much any Python editor will do for you, then yeah, you're good. Okay. Yes.
Will it change anything if you use UIK is equal to UIK minus MJ times U here in the row operation?
Okay.
Will it change anything if you instead of using UIK minus equals to that?
Oh, okay. So in other words, this. All right. So what I have here is equivalent to that. Yeah. So it's a nice shorthand that MATLAB doesn't offer. Yeah. So this equals itself minus this, and similar like in the previous file, we had plus equals for summing. Yeah. So another convenience. Okay. Now, God help us, let's go ahead and run this thing. Before, I want to have it print out A beforehand, and then we'll have it print out U afterwards. I'll give some labels. Single quotes, yeah. Okay. All right. Please work. It's a very bad idea for me to just write code on the fly. Okay, this is not easy to read. I'm going to make a smaller matrix. So first I'm going to make this right window a little bigger, and I'll set n equal to 5. It appeared to work, but I want to be able to more easily see. Okay, so let's just do this again. All right. I was hoping that it would. Okay. Fine. I'll do 4. I was hoping it would change its line length. Okay, now we can easily see what's going on. So, yes, it reduced it to upper triangular form. So that seemed to work pretty well. Now, it turns out, though, that intentionally, there is something terribly wrong with this code. But it's not obvious at all. Because we have A and U appears to be correct. But now this is just basically a script that's just run. So these variables are available. Oh. That's weird. Okay. I thought I could print these out. Okay, I'm going to try running it differently. Run it this way. So I'd like to be able to access these variables in here. Ah, okay. So if you import, then it looks like you don't have access to these variables. Okay. Well, that's awful. So what it must do is run in its own workspace. Now I could import things from it, but I just want to. But that's not really what I'm interested in for using anything else.
I don't understand. You ran it the first time, and you tell it what n is. So now why is it saying n all the time?
Yeah, but, so apparently that's a consequence of how.
Did you type n in the over here in the command area, and it said it didn't know what happened.
Yeah, so apparently what happened was, okay, I'm going to try this. Well, actually, what I want to do is I'm going to create a new console without destroying the old one. Okay. All right. So, yeah, if I go ahead and import NumPy, not NumPy, GaussLM, it will run it, but nothing. Oh, I think I know. Here's what I can do. I can do GaussLM .n. So you can do that. You can access variables that way. Now, if I don't want to type GaussLM dot all the time, I could do from GaussLM imports everything. And then I can do n by itself. I can also do u, and so on. So, okay. Yeah, so that's how import behaves, as opposed to if you run it as a script. Like, so if I'm using a run button up here, then so running this, like using a run button, is equivalent to if you type those very things at the prompt. Whereas import is not. Or it's like it's running in a separate space. Okay. So import is by default so GaussLM, or whatever I'm importing, is referred to as a module or package, and so that needs to be used as a prefix unless you do something like from GaussLM import star. Okay.
And so if you like have a bug and it can run a bug, and then you want to see what
Right. Yeah. Well, yeah. Well, if it's changed, you need to do it anyway. But okay. I realize I have two consoles going, so I'll splice these together when I post it. Okay. So back to my original console. Since I ran it as a script, I have U here. Now, here's A. Oh, wait a minute. That's weird. Oh, this is the original. Okay. That's weird. Not sure where this came from. Because when I'm printing out U, it's not this U, it's this U up here, from when I ran it as a script. Okay, and these other ones, okay, these are ones of different sizes. So I'm honestly not sure where this one came from. Okay, I'm just gonna run it again as a script. Okay, so now this is one we're working with. So here we have N, we have U. Now, note what I did in the code. I generate A, print it out, and then I assign it to U, and I do all the work on U. But let's take a look at A. Notice, A got modified too. That's bad. This is not how MATLAB would behave at all. And here's why. They're assigned or passed by reference in Python, but by value in MATLAB. Now, what does that actually mean? So this is where I get a little more computer sciencey on you all. So passed by value means so you make a copy of the data. So for instance, a statement like U equals A in MATLAB would allocate a new array for U and then copy every element of A into the corresponding location within U's allocated space. Passed by reference, the address is passed. So address of. So what this does is U equals A does not copy the data from A into another location assigned to U. It takes the address of A and assigns it to U. So U and A point to the same location in memory. So what that means is every time I do something to U, it does the exact same thing to A. Because it's working through the same address to get to the same location of that entry and modifies it.
So when you say work on U, you're really saying work on A.
Yes.
Work here.
Yeah, work on A through U. So for those of you who are accustomed to the MATLAB way of doing things, this sets you up for a whole lot of heartache. So we have to do things a little differently. So I'm going to comment this out. We don't want to do that anymore. Here's what we'll do instead. U equals A dot actually I need to check my syntax here. Because it's been a few weeks since I did these things. Um,
So equals is like a left side of the equal sign is like the location.
yeah. So now, okay. Oh, it's a little different. Okay. I'm gonna cheat for a second here and open up a file where I've done this. Okay. Oh, all right. So you can't do it either way. All right. So you can do a dot copy or u equals np dot copy a. Either way would work. So now if I go ahead and run this, okay. So there's u. It's upper triangular, but now I print out a, and the original a is preserved. Okay. So all right, so this has the desired effect, that A will not be destroyed anymore. Okay. All right, so this is one cautionary tale when it comes to working with arrays, matrices, etc.
So when you did it printed everything twice. You see how the top has the
Oh, that's weird.
so it prints out copy you and then a change from
Okay. Hold on a second. Okay, I'm gonna run this again. I like it ran it twice.
and then it's changing
Yeah, and then by extension U. That's really weird. Why is it doing that? Unless no. Okay. If I instead do it this way, oh, in this case it did. Wow, now it didn't do anything. What on earth is going on here? Okay, that's the previous one. That is absolutely insane. Okay.
Can't we use the copy syntax to the after a equal np dot random that syntax?
Oh, well, you wouldn't want to copy up here because here you're creating A for the first time. You just want to make sure that U and A are stored in separate spaces. Okay. That is the most insane thing. Well, if I go to the okay. Oh, okay. I'm gonna run this script here at the prompts. What? What do you mean it can't find it? It's right there. Did I spell it wrong? Gauss 11. Gauss elim.py. Am I losing it? Oh, I needed to actually put the .py in there. Okay. And here it decided to print it out and work on it only once. So, So I don't know if something is messed up with a console or something, or yeah, because this is how it ought to behave. Um, yeah, because before when I would import it up here, it would actually. Okay, why is it even doing that? It's putting that all over again too. That is really freaky behavior. Okay, if I go over to this console, prints it once.
I think that console.
Is messed up
You know,
a little bit. Yeah. Okay.
Well, it was printing it twice when you used the run button, right?
Well, okay. Now let's go to this console over here and run it that way too. Once. Okay, we have a sick console.
I don't understand why, like the one you just did, the format is so much bigger than the one right above it. What's the difference there? Why is that?
Oh.
It's like when I run it the first time, it's big, and then when I run it the second time, it's small like that, and compact and nice. Why?
Yeah. The only thing I can think of is that if there's some different default print format assigned to when it's doing run file, like, well, actually, let's compare this to when I was in the command window. Okay, it looks like that. So it's like as if it's running a script. Although, well, let's see.
Well, if I'm clicked in my script and I press the like green arrow,
Yeah.
it's big. But if I click inside the command console and I click the green arrow, it's small. So it must be default for the command line versus default for the script.
Apparently, yeah.
That's what's
Yeah. Oh, so now when I import, it won't print anymore. I've broken Python.
Is there a way to like set the seed for the random command so that you get the same thing each time?
I imagine there is. Oh, yes. So np.random.seed. By default, no arguments, or you can pass a seed. Okay. All right. Yes. So if you pass a seed, then yeah, that will have a desired effect. So in fact, let's try that. np.random.seed, and I'll just pick a number, 20. Has to be an integer, or something that could be converted to an integer. So now, if I run it twice, prints twice. Now if I run it again, it's the same. Okay.
What does the 20 mean?
You just pick a number. Like now by default, it takes no arguments, and that will cause something. Let's see. What will happen in that case? Okay. Well, I guess even. Yeah, so I can pick any number to start it at a random spot. So I guess the way is to add your own randomness. Okay, so now both consoles are messed up.
Is there a way that you can clear all of your variables like you do in MATLAB?
Let's see. There should be. Actually, can I unimport? No. Okay. Oh, I think I just cleared the screen, which is a bad idea because I hadn't saved that yet. Well, I have a commands here. Although, yeah, today's log is going to be interesting since it's spread across two consoles. Okay. Okay, so that's something that would be Oh, okay. Come on. Dang USM internet. Oh, okay. So if I do % reset, okay. Okay, so here's the help page on reset. So it's something that's preceded for %, so it's something that you would do at the prompt to clear whatever's there. So just % reset will clear everything. Oh, it asks you if you're sure, which is good because if you try to clear something in MATLAB, that's so destructive. But you can do clear-f to not.
Does that like unload whatever packages you have loaded as well, or is that just variable stored?
Yeah. Well, okay. Let's find out because right now, for instance, I could do np dot. All right. So for instance, I could do that. So now if I do, let's do a clear. No, reset. Okay. Now let's see if I can do that. Yeah, it unimports everything too. Yeah. All right. So now let's run this dang script again. Won't print anything. Run it. At least it's only printing it once. I guess that's progress. Okay, Python appears to need a little work. Fantastic. Okay. Now, let's see. Okay, so that was Gaussian elimination. All right. So, one other thing I want to point out is another form of copying. Here we go. Now, copy, as I just showed you, is okay. Okay. So if I do, so as I showed you, do we have A here? Yes, we have A. So use copy. You want to create a new memory location. So like B equals A dot copy, and I now have B that's equal to A. But now if I change an element, that will change B, but it will not change A. Okay, so that's the usage that I've just showed you. But now, here's a slightly different situation. Suppose you want to make a copy of something, but you don't want to, like, say you're in a loop, and you have a copy statement like this. It's creating a new memory location, new allocation every single time for a loop. But you might not want to do that. If this is a variable that's local to a loop, so it's like it's only used inside the loop, you might want to allocate its space the first time through, but then on subsequent iterations, not use copy to allocate a new array, but reuse that space and copy something into it. Use copy to. So now what I'll do is I'm going to so the way that would work is np.copy to and the destination first, and then the source where you're copying from. So I'll just put U in there. So that's the simplest usage. So now, B is set equal to U that was generated earlier. But unfortunately, I don't have any way of printing it out here. But this address of B is the same as the address of B up here. So, because what would happen is, suppose I did copy again here, then this address of B would be different from this one. Not only that, because B is associated with would be a new space. This is lost now. I have no way of accessing this anymore. Its space has been allocated, has no variable to reference it. It's just sitting there taking up space in memory. In other words, it's wasteful. So think about that, especially when you're dealing with loops. Do you want to use copy or copy to? Because if you're going through a loop, what you might want to do is allocate something before the loop starts. And for that, you can go ahead and use copy or array or something like that to create something new. But then use copy to copy data into it without repeating the allocation every single time. So it's something that saves memory and ultimately would save speed as well.
I got a question.
Yep.
Back on clear and reset. Does that clear your history file?
Probably not. But okay, actually, here we go. Okay, so these are parameters I can pass to control what it resets.
So you put that in parentheses after reset?
It looks like what I would do is use it as spaces.
Okay.
Yeah. Unfortunately, not something I want to try in the middle of class, but yeah. No. Okay. Oh, this is interesting. Clearing out your arrays, you can do that also. Okay. Here's some examples. Oh, yeah. So here's an example of flushing the input history. Okay. All right. At least here is something useful I can put in a log. God, I'm not looking forward to that. It's going to be such a mess. Okay. So any questions about this debacle?
So I'm really confused now because, like, if you have a variable that's passed, like, from a main calling function to
Yeah.
a function somewhere else, if you're passing something and you use copy, then you're really passing in a pointer address, right?
Yeah.
Variables.
Well, yeah. What will happen is because it's passed by reference. Yeah. If you have a function that accepts an array as a parameter, and if you start changing its entries, or if you just assign it like u equals a, and change entries, that will change the original parameter that was passed because it's by reference. So very important in that case, since you're monkeying around with someone else's data, to do a copy in that case. So when in doubt. Okay. All right. Now, so a couple more things I'm going to assign. Okay. (1.2.18) up to 19. These are just similar to what's going on with Gauss-Lim, which I'll also put on the site. So you make files like matadd.py, matmul.py. I said pi or py. That will you can create a random matrix, and then or in this case for this case 2 random matrices A and B of appropriate sizes, and then also matrix C of an appropriate size that would be the sum or the product of A and B. So using the appropriate loops to implement that. Okay. So V's right here. And okay. Now, of course, matrix addition, very straightforward. Multiplication, less so. All right, so A, I, K, B, K, J. So you'd be accumulating this product. Of course, this is how it's written mathematically, because you got to adjust the indexing for Python. Okay, so let's see. All right, where are we at here? All right, so at this point is where we'll take a break, and then like 15 minutes or so, and then when we come back, so I've assigned you okay, so 1.2.15, 16, 18, 19, and this is in the text that I sent before the semester started. So you can look up all those for the full problem description. So what we'll do is, since I have no idea how long this will take, but the idea is when we come back, or you guys can start right away, and let's see how many of these we can all do. I'm depending on how much time we have left, I may continue covering stuff. We'll just see how that goes. It's been an adventure. Okay. Oh, I still can't get that? Okay. All right, so I need to send find max, and I'll send Gauss-Elim.
Now I see find max.
Okay. All right, so let me. Okay. So. Okay, compute mean was posted last time. Find max apparently can be seen now. Okay.
But I opened many tabs.
Oh, that's weird. Okay, and then 18 and 19, they're kind of like Gauss-Elim, which I haven't posted. I'll go ahead and post it, but I'll also, okay. Okay. I'm gonna actually upload it. Okay, let's make sure it's there. Okay, it's there. Now, okay. Okay, we'll see how this goes. Oh, I'll stop the video for the time being. All right, so shorter second segment. We'll see how the console behaves this time. Now, we've seen if statements, we've seen for loops. Put the two together, you have a while loop. So it's a loop that runs according to a Boolean condition. So I'm going to show you a couple of scripts that I've written that illustrate the use of while loops, and I'll post these on the site also. Okay. All right. So guess number. So what this does is it chooses a random number, a random integer between 1 and 10. Now, if we see how this is done, np.random.rand with 1 will choose a single random number that's between, if it's a floating point number, between 0 and 1. So then multiply by 10, so now it's a random number between 0 and 10. And then we use the math.ceil function, CEIL, short for ceiling. So, random floating point number in 0, 10, rounded up to the nearest integer. So a variable number holds that random integer that's now going to be between 1 and 10 because we're rounding up. Okay, so then I have it print out a prompt. I'm thinking of a number between 1 and 10. What is it? Enter your guess. So the input function, which we've seen before, from the enter month year, or enter month year script, displays this prompt, asks the user to enter an integer. So whatever they type will be converted to an integer, if possible, and stored in the variable guess. So now we have number and guess, and they need to match. So this while loop will run as long as number and guess do not match. So the while loop, just like a while loop in any other language, it runs as long as the condition in the while loop is true. So as long as they don't match, inside the loop, I'll have a new prompt saying that your guess is wrong, try again, enter another number. It'll keep going. And finally, when number equals guess, when they do match, that's when the loop terminates. The condition is no longer true. So now control passes down here to this print statement saying, finally, he guessed right. So if I were to run this, okay, I'll just run it this way. Okay, so I just choose a number between 1 and 10. So I'll pick 5. I have no idea what the number is. It's random. Okay, I guessed wrong. Let's just pick another. And now I get desperate and just start from 1. Okay, so on the 4th try, I got it. So this is what it prints out before the loop starts, and then the loop ends up running 3 times because I entered 3 wrong guesses. Once I got it right, then we came down here and printed this message. Okay. So any questions about the general idea of how a while loop works? Notice, just like with other statements we've seen, like if statements, for statements, after you have your while keyword and then the condition, a colon, and that tells the Python editor, now it's time to indent for the body of a loop. Okay. All right. Now, I have another example that's a bit more mathematical. Actually, it's a lot more mathematical. Newton's square root. So Newton's method for f of x equal 0. You choose initial guess, which I'll call x naught. And then the iteration is xk plus 1 is equal to xk minus f of xk over f prime of xk. So what I'm doing in this example is f of x is equal to x squared minus 2. So the root of this function is plus or minus the square root of 2. So now, if I use this f of x in this iteration, then I have xk squared minus 2 up top, and then derivative is just 2xk. And if I simplify that, I have xk squared over 2xk, which is the same as xk over 2. So this simplifies to xk over 2. Minus and minus makes a plus. This 2 cancels with a 2 down below. So I have 1 over xk. So this is an iteration, xk plus 1 is equal to this, that is actually can be proven to be guaranteed to converge to either square root of 2 if the initial guess is positive, or minus the square root of 2 if the initial guess is negative. Okay. So that's the idea behind this script right here. So I just choose an initial guess of 1, because the square root of 2 is approximately 1.414, etc. And I put a dot here to force it to be a floating point number. And so I display what we're about to do, computing a square root of 2. And here I have it set up to be an infinite loop. So the special variables true and false are defined in Python, but notice they're capitalized, whereas in MATLAB are not. So while true, so this is a loop that will always run. So something needs to happen inside the loop to cause it to terminate, or it really will run forever. Okay, so what I do is I save the previous iterate. Now here I'm not doing any copy stuff, because in this code I'm not dealing with arrays at all. Copying and so forth is only needed for array variables, not scalars like what I have here. So now this is the Newton's method formula that I showed over here. So this will compute the next iterate. I'll print it out so we can see the progress towards convergence to the square root of 2, and then here I check for convergence. So I look at the absolute value and check whether it's less than the absolute value of the latest guess times 10 to the minus 16th. So if this condition is true, I decide that the iteration is converged and I want to get out. So just like in other programming languages like C or MATLAB, you can use a break. So a break will cause the enclosing loop, which is a while loop in this case, to immediately exit. So that means as long as the iteration is convergent, the loop will terminate. But it's not really the best idea to have an infinite loop like that. You want to make absolutely certain that under any circumstance that the loop will end. So then I go ahead and display the value that I got, the x, and then just for fun, we go ahead and square it, just to confirm that, at least aside from floating point error, round-off error, that the square really is equal to 2. Okay, so any questions about what the statements are doing?
What did you say about the capital things are capitalized?
Oh, for true and false, to refer to those basically Boolean literals, you capitalize. was now wondering, like, if I go ahead and type these as a prompt, like true. Oh, okay. I thought it might display like 1 or 0, but basically 0 is interpreted as false, and non-zero value is interpreted as true. Okay, but if I type in, okay, yeah, so the non-capitalized it doesn't know what that is. Okay. Actually, I'll go ahead and run this. Okay, so here are all the iterates, and after 1, 2, 3, 4, 5, 6 iterations, well, the last two seem to be essentially equal. Although it's not as accurate as I would have liked as far as the squaring. But yeah, it's very close to 2. Now that I think about it, I'm going to do this in MATLAB also. I want to see how the results compare. Okay, good. We can see both at the same time. So if I do x equals 1, and then I just run the same iteration, x equals x over 2 plus 1 over x. Okay, I want format long for this. Okay, so I'll keep doing it until no digits change. Okay, so actually, yeah, the values are the same from what's displayed. And if I square, okay, that's interesting. That okay, look at how many decimal places are displayed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Whereas over here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It displays one more decimal place. Now, just for fun, I'm going to look at the floating point representation of this number. For that in MATLAB, you can do format hex. And, okay, so what we have is, whoops, I'm using a wrong common character. The sign bit is equal to 0. Now, the way this breaks down, here we have 64 binary bits expressed as 16 hexadecimal bits. So if I break this down into binary, it would be, this would be, so the 3 would be 0, 0, 1, 1. That's 3 in binary. And then the F's, that hexadecimal digit F corresponds to 15 in decimal. So that's 1, 1, 1, 1 in binary. So we have a bunch of 1, 1, 1s all the way down to the end until 1, 1, 1, 0. Okay. Now, the first 3 of these blocks refer to the exponent. Well, actually, the first, okay, sign bit is the very first one, 0, because it's a positive number. The exponent is 11 binary digits. Now, okay, so 15 is 4 digits, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is equal to 1023 in binary. We subtract 2, 3 to get exponent, which is equal to 0. And then the mantissa is the rest of a floating point number, all the remaining binary digits, so all 1s, all the way down to a last bit of 0. So in that case, that would be equal to, there's an implied 1, so it'd be equal to 1 plus 1/2 plus 1/4 plus 1/8, all the way down to 1 over 2 to the, okay, there are 52 of these overall. So 2 to the minus 1 down to 1 over 2 to the 51. Okay. Now that is a partial sum of a geometric progression, geometric sequence. So we can actually figure out what the sum is. That is equal to 2 to the minus 52 minus 1 over, okay. Oh, whoops. Oh, did I? That doesn't seem right. Oh, I know why. It's not 2, it's 1/2. That's my ratio here. Okay, so nearly 2. But yeah, there's a little bit of error in here. So if I try to simplify this, this is equal to, so dividing by, so really what I have is 2 minus 2 to the minus 51, which is equal to that value there. So that is the error. And actually that makes perfect sense, because if I subtract this from 2, then I get 1.9996. And okay, so it makes sense. Now, it's one binary bit off from the floating point representation of 2. So if I look at x squared, okay, so that's what we had before. I'm going to add to this 2 to the minus 52. And now we have all that. So then it's the smallest number that is strictly less than 2. If I add one more bit onto it, that's 2 exactly. So so you see, if I took 2 to the minus 51 and added to this value, actually, let's do that over here. Okay, plus 2 raised to the minus 51. And it considers it 2. Okay.
So Python displays one extra digit than beyond MATLAB, and that digit lets us know the error.
Yeah, it is one more digit. Yeah, and so actually it gives us a windows to how much a floating point error really is, which is quite nice actually, because that it indicates pretty much the limits of floating point precision. Okay. All right. Now, okay, where are we at? So I have. Wait, where am I? Okay, so regarding this Newton square root, I have a couple more. So there's a couple variations that I'd like you to try to figure out. So this is a MATLAB version of Newton square root. Okay, 1.2.20, 1.2.21. So I'll now talk about those. Okay, so each one of these it calls for a variation of Newton square root. So at least you have a starting point, and I'll be sure to put that on the site momentarily. So what happens is, well, in the first one, is to change the way the while loop is written. So that's not an infinite loop. Instead, it's using the condition for convergence as currently inside the loop, but it uses that in the while statement. Now, notice I make a comment here. Yeah, while statements use a condition given in the if statement, or really it's logical negation. That's very important because while loop will run as long as the given condition is true. But the if statement that we have over here, this is the condition under which the loop ends. So you have to use a negation of this condition up here. Now, one comment I'm going to make about this is, I'll type it out here. To use if statement condition in the while statement, you must ensure that all variables are defined. So what I'm saying, so what I mean by that is, if you just take that condition, negate it, and put it up in a while statement, it won't work. Not all variables in the statement are given a value. So make sure they're all given one, so that so it makes sense, and then the loop actually proceeds.
So you have to initialize them.
Yes.
before you get in there.
Yes. So once you run it, the output should be exactly the same. But now it's not using an infinite loop and a break statement, which is kind of cumbersome. Okay. So that's one variation. The other variation in 1.2.21 is have an extra criterion for stopping. We're going to keep track of a number of iterations. So you need a variable, so you can call it this, n-iter for number of iterations, to make sure that the code will not perform more than 10 iterations. Now, in this example, it doesn't need that many iterations anyway, but this way, so for general purpose code, if you're implementing some sort of iterative method, you should always impose some cap on the number of iterations. Just because you don't want to have something where it's literally running forever and never converging. It should stop for some reason. So like when MATLAB implements iterative methods, it has a default number of maximum iterations, which you can change. And then it will use an output variable to indicate whether the method succeeded or not. And so based on a variable, you can see, oh, it converged, or nope, it got to the maximum number of iterations and it not converged yet. So you can actually tell what happened. Okay. So like, Brianna, when we're saying, oh, interrupt this. Yeah, so we don't have to do that. Yeah. So, okay. Now, for this, you have a compound condition. So you'd have a condition involving something like this, and using an and or an or. So for 1.2.21, for these kind of conditions, and and or actually spelled out. So keep in mind, if you use an and, that means that both items must be true for a loop to continue. If you use an or, then only one of them has to be true. So think about which one do you want in this case. Okay.
Sentence again?
Like if you use an or, then the loop will continue as long as one of the conditions is true. Although it turns out in the problem statement, I gave it away. You want an and. Okay. All right. But, think about why that is, why that's the correct thing to use. Okay. All right. Okay. Well, yeah, my streak of giving away answers continues, I guess. Okay.
But we're free to try an or if we want to.
Yep. Well, let's see. So in this case, if you use an or, then it'll keep. In this example, which only needed like 5 or 6 iterations to converge, it would keep going up until 10. Well, now what I'm wondering is, if I run this code again and I change the tolerance like 10 to the minus 17, what will happen? Oh, didn't get any better. Oh, maybe it's because. Okay, let's try 10 to the. Well, the 10 to the minus 18. That's pretty dang small. So that's interesting. Well, yeah, but the iterates are essentially equal to each other, and that's why the loop ends. I was hoping to get more accuracy, but it was not to be.
I think that has to do with the limit of the floating point calculations that they have here.
Mm-hmm.
I tried that. I just threw in a number like 10 to the minus 100.
Yeah.
I know that isn't the right way to
Yeah.
for self-evident reasons.
Yeah.
But it's a good way to see if it'll get any better.
Yeah. So, well, dang. So, well, that's good to know. Okay, so I will put both of these while statement examples. So Newton square root and guess number, as well as the rather screwy tutorial script, all the commands that I ran today. Okay. All right. So let's see. Where are we at now in the tutorial? Okay. Well, actually, I think this is a good stopping point. So then I'll pick up next time with functions, writing your own functions, and then depending on time, getting to graphics. So if you have any difficulty implementing these other ones or ones from earlier, let me know. I want to make sure that by the time we start on Thursday, everybody is good with those at least, because I'm going to throw more out there. And soon we'll have some graded assignments. So, yeah.
So you don't necessarily want us to email you these?
Well, it'd be good to anyway, just so I can give feedback as needed. So, yeah. But if you feel really good about them, then okay. Yeah. Alrighty.